So one of the tricky things about the z-score equation for the sampling distribution of the sample mean is it relies on us knowing the population mean and the population standard deviation. In a lot of cases, we can find information on the population mean, or we can find a previous study to reference for a value of the population mean. But it is much harder to find a value for the population standard deviation. And sometimes it just cannot be done. So when that happens, which is most cases, we compensate by using the standard deviation for the sample as our best guess for what the population standard deviation might be in that z-score equation. However, when we replace sigma with S, so we take sigma and we say, you know what, we don't know what that is, so we're going to use S instead. Because this guy is just too hard to find. Maybe even impossible. When we do this replacement, it changes our distribution, and we no longer are following the normal distribution. The normal distribution relies on mu and sigma, not S. So this new distribution, where we know mu and S, is called the t-distribution. So the t-distribution, formerly known as the student's t-distribution, states the following. Suppose a simple random sample of size n is taken from a population. This t-score, which is interpreted very similarly to a z-score, it tells you the distance away from the mean in terms of standard deviations, is found by calculating t equals x bar minus mu divided by s over the square root of n. So right here, this is the change that we made. We didn't know sigma, so we swapped out sigma for s. And by doing that, we have changed this from a z-score to a t-score. So some properties of the t-distribution. The t-distribution changes depending on something called the degrees of freedom. Degrees of freedom is equal to the sample size minus 1. So every time we take a sample and the sample is a different size, the degrees of freedom is going to differ, which means the way that the probability is calculated is going to be slightly different, because every t-distribution that has a different sample size is slightly different. The second property is that the t-distribution is centered at and symmetric about 0. That is the same as the normal distribution. The area under the curve is 1. That's also the same as the normal distribution. And the last property, as the sample size increases, the t-distribution gets closer and closer to the normal distribution. This occurs because as n increases, the sample standard deviation gets closer to the population standard deviation by the law of large numbers. So as we increase our sample size, we're getting closer and closer to the population size, so the sample standard deviation is getting closer to the population standard deviation. So some examples of what these curves might look like. This curve might represent the normal distribution. It's a little lopsided. And then we might have this curve that represents the t-distribution, with a sample size of 30. And then this distribution might represent a t-distribution with a sample size of 50. And then I'll throw one more in there. This one could be a t-distribution with a sample size of 75. So the sample sizes are changing and therefore the distribution changes, and these are not exact pictures. This is just to give you a general idea of what is happening. But as the sample size gets bigger, the t-distribution curve is getting closer to that normal distribution curve. So again, this happened because we don't know sigma, the population standard deviation. So we replace sigma with S, the sample standard deviation, and it causes us to change the sampling distribution that we're looking at slightly. It's still bell-shaped. It still is centered at 0. So this would be 0. It still has an area of 1. There are a lot of similarities between the t-distribution and the normal distribution. But the biggest difference is you have to know the sample size and the degrees of freedom, because that's going to affect which t-distribution you're looking at. And that's the t-distribution.